Alright, for quiz 3 here, first of all, we got to draw a tree diagram to identify the sample space of rolling a 6-sided die followed by a coin, flipping a coin. So remember, whatever's listed first, you're going to want to list first on the tree diagram. So it says we're rolling the 6-sided die first. So your possibilities there are 1, 2, 3, 4, 5, and 6 whenever you're rolling a single-sided die. Something on this order. And then we're rolling the coin next for this case. So then that would mean we would have heads and then tails following that for each of these. So those are your possibilities there. If we had it listed as heads, or flipping the coin and then rolling the die, then these would have been reversed. We would have had heads and tails first, and then off of the heads we would have had the 1 through 6, and then off of tails you would have also had 1 through 6. So you want to make sure that you're careful what order those are listed in order to get your tree diagram correct. And then remember, a sample space is what you have for all of your possibilities. So in this case, for instance, our sample space, we have 1 and heads as one possibility there. That should be an H there. And then we'd have 1 and then tails and so on. And then to figure out your probability here, in this case I wanted the probability of rolling between a 2 and 4 inclusive. So if we're talking about between a 2 and 4 inclusive, that means you're including the 2 and the 4. If it just said between the 2 and 4, then it would have only been the 3 that was included there. So you want to make sure you're reading those carefully as well. And then we want an and flipping a tails. So between 2 and 4 inclusive would mean all the 2's and the 4's, but also the 3's. And flipping a tails means it has to be a tails also. So in this case, we have a 2 tails here, 3 and tails here, 4 and tails here for this one. And then if you count all of your possibilities here, once you get them all listed out, there's a total of 12 possibilities. So in this case, your probability would be 3 out of 12. It simplifies down to 1/4. Or you could also write that as 0.25 as a decimal, or you could write that as 25% if you want to write it as a percent as well. So that would be for the first one for that probability. You want to make sure you're showing all of that work to receive all of that credit for number 1. The next one, how many ways can you make a sandwich using a type of bread, 2 types of cheese, 2 types of meat, if you have 3 types of bread, 6 types of cheese, and 7 types of meat to choose from? So this one is using your combinations here because we're choosing those. There's no specific order, so it'd be combinations. So for the first case, we'd have 3 types of bread, and we're choosing one of those. So we can write that as 3C1 for a combination. And then we're using that fundamental counting principle. So then you multiply that times the number of ways to choose the cheese next, which was 6. And then you're choosing 2 types of cheese times, and then we had 7 types of meat to choose from, and we're selecting 2 of those. And for this, make sure that you're also writing out the formula for your combinations here to receive full credit. So here for this first one here, we would then have the 3 factorial over, and then make sure to put that entire denominator in a parentheses, and the stuff in between that also needs to be in parentheses. So you do the top and bottom separately. It's another way of thinking of it. So remember, those exclamation points are your factorials. And then you do that times, and then do the same type of thing for the next one. 6 factorial over, then all grouped together in the denominator, you'd have your 6 minus 2 factorial. Make sure you're doing those subtractions before you do the factorial part. You cannot distribute through a factorial like you can with your integers. So make sure you don't try to do that. Make sure you're doing the 6 minus 2 to get the 4 factorial in the bottom there for that 6 minus 2 factorial part. Similarly here for your 7c2, 7 factorial, then you'd have 7 minus 2 in parentheses factorial times your 2 factorial. And then all of that grouped together. So then here for those answers, if you do them correctly, you should have 3 times 15 times 21. And they're all being multiplied. We're using that fundamental counting principle again. So you get 945 for your answer there. Once again, make sure that you're showing all of that work, even if your calculator has the combinations on there to calculate for you. You need to make sure you're showing your work with those factorials as well, or at least show me that you know what the formula is there. Next one here, you have to determine the following are independent or not. Explain your answer. So here we're driving drunk and getting pulled over by a police officer, if those are independent or not. So remember, independent means that they do not affect each other at all. They have no influence on each other at all. So it is not a cause and effect thing. It is just some sort of relationship, some sort of influence on each other. So if you think about it, if you're driving drunk, you are more likely to get pulled over by a police officer. It doesn't mean that you will be, it just means that you're more likely to. So that would mean that you have a case here where they are not independent, or you could put dependent instead. So they're not independent, which means they are dependent. And one way to explain that is because you're more likely to be pulled over. So we could put it, instance, more likely to be pulled over. When driving drunk, or something to that effect. Something that shows that there's some sort of influence on each other there. Does not mean that one will cause the other one. That's a totally different thing. Just that one influences the other's likelihood of happening. And then for number 4, to determine the probability, randomly selecting a card that is king or a heart from a standard deck of cards. So remember, king is one of your values. So remember, each of your values, you have 4 of those because you've got 1 for each suit. So in this case, we'd have a 4 out of 52 chance of getting a king, plus, and then of getting a heart. Heart is one of those 4 suits. And you've got 13 of each of those suits, so you'd have 13 out of 52 there. Minus, and then we'd have 1 of those kings, that is the king of hearts. So you need to subtract that off so that way you're not counting the king of hearts twice here. So in this case here, it looks like we get 16 out of 52, which then simplifies down to 4/13. And once again, you can either simplify that fraction like that, or you could go ahead and divide those, get that as a decimal or a fraction there as well, would also work. So you want to make sure that you're careful whenever you're doing those to simplify it correctly as well.